to keep the trains running on electricity. Engineers have been working on it for 100 years. This is the history of the pantograph. It doesn't look like much, but it's a tough nut to crack. The first pantographs were relatively simple. It consisted of a copper conductor and a spring structure. The copper conductor relies on the force of a spring. The copper conductor is held in contact with the wire by the force of a spring to supply power to the motor. However, due to the lack of stability and excessive friction, this can easily lead to equipment damage. To improve stability, engineers have improved it. The same conductor was tilted backwards. The springs and the support structure of the electrodes were readjusted. This resulted in a significant improvement in stability. But then a new problem was discovered. The strength of the springs could not be controlled. It was easy to break the cable, so the engineers added a rope at the back to balance the spring force. That solved the problem. In order to make the wires more accurate, the engineers added a slotted barrel. They added a slotted barrel. But in time, the problem was solved. Because of the continuous movement of the train, the groove would inevitably wear out. It had to be replaced more often. So the engineers replaced the contacts. They replaced them with long metal rods, and the cable was designed in the shape of a snake. The contact point of the contact head is constantly changing. The contact area is increased. This greatly reduces the wear on the head, and to minimize wear on the overhead cable, the engineers added carbon strips to the contact surfaces, so that even when the train is traveling at high speeds, and the side corners have been extended, it's called a bow collector. This design allows the train to switch tracks to allow for a smooth transition between overhead cables. Otherwise, the cables could get caught under the head of the collector, but as the train's speed increased, problems became apparent: air resistance and vibration. The reason for this is that the airflow creates a vortex behind it to solve this problem. In 1903, the engineers changed the pantograph to a two-armed, a symmetrical structure. This solved the problem of vibrations. The pilot could also control the height of the pantograph by observing the height of the cables. The driver could also control the height of the pantograph by observing the height of the cables. But this double-armed pantograph is large and heavy. It is not energy efficient. They are not flexible. To solve this problem, engineers utilized new technology. They designed a single-arm pantograph. At its base is a 4-bar mechanism. The contact head is mounted on the end of the yellow rod extension. The height can be flexibly adjusted, but the angle of the friction head will change according to its height. The contact with the overhead wires, it becomes less effective, but the engine